Assalamualaikum and good day to everybody. Today we are going to start with topic 7, gravitation. This topic has 3 subtopics, which are 7.1 gravitational force and field strength, 7.2 gravitational potential energy, and 7.3 satellite motion in a circular orbit. Okay, the learning outcomes for this topic. At the end of this topic, students should be able to, for subtopic 7.1, state and use the Newton's law of gravitation and define and use the gravitational field strength. For subtopic 7.2, students should be able to define gravitational potential energy and use the gravitational potential energy. Lastly, for subtopic 7.3, students should be able to derive and use escape velocity and derive and use equation for satellite motion for velocity and period. Let's start with 7.1. Gravitational force and field strength. Any two bodies with masses can attract each other. This universal effect is known as gravitation. The force for which one body attracts the other due to their masses is known as gravitational force. The symbol that we use for gravitational force is capital F. Let's consider this situation. We have two objects. One is M and the other one is capital M, separated at a certain distance r. So these two particles will attract each other through gravitational force. Even if the particles have very different masses, the gravitational forces they exert on each other are equal in magnitude. Remember, the distance r is always measured from the center to center of the two particles. So what is Newton's law of gravitation? Newton's law of gravitation states that every particle in the universe attracts every other particle with a force F, which is directly proportional to the product of their masses and inversely proportional to the square distance between their centers. To state Newton's law is the learning outcome of this topic. So remember, this is the statement of Newton's law of gravitation. Or, mathematically, we can also write Newton's law of gravitation as F directly proportional to the product of the two masses and F inversely proportional to the r squared. And combining these two relationships, we will get the equation of the Newton's law of gravitation, which is F equals to G M capital M over r squared, where F is the gravitational force, G is the universal gravitational constant, the two M's are the masses of the two particles, and lastly r, the distance between the two particles, which again must be measured from the center of the particles. The gravitational force F acts along the line joining the center of mass of the bodies. Okay, let's consider another situation here where we have two objects. One is M1 and the other is M2. So the two forces acting on each masses will be denoted as F12 and also F21. So what does F12 and F21 means? F12 is the gravitational force on particle 1 that is caused by particle 2, whereas F21 is the gravitational force on particle 2 by particle 1. Okay. M1 attracts M2 with a gravitational force which is equal in magnitude but opposite in direction. So if we look here, F12 is acting to the right and F21 is acting to the left, but their magnitude is always equal. Okay, that is F12 equals F21 in value. Okay, so these two forces is known as action-reaction pair, which is the Newton's third law of motion. Okay, so what about the graph of F against distance r? So for F against distance r, the graph that we have is inversely proportional or a decreasing graph. Doubling the distance between the masses causes the force to decrease by a factor of 4. And for a graph of F against 1 over r squared, the graph that we will get is a straight line graph, and the gradient of the graph will be equivalent to GMM. Okay, let's try to solve this example. What must the separation be between a 5.2 kg particle and a 2.4 kg particle for their gravitational attraction to have a magnitude of 2.3 times 10 to the power of negative 12 Newton? So this question asks us to find the distance between the two objects, 5.2 and 2.4. So how are we going to solve this question? Okay, we know that the equation for gravitational force is given by F equals to GMM over r squared. And we are already given the values of the force and the two masses. So substitute all the values in the equation. And from calculator, we will get the value of r, or the separation distance between the two objects, is equals to 19.02 meter.